In this video, we're going to learn the basics of trigonometry, which is a fundamental mathematical tool for the study of physics. And because this is not a math video, we will not do any rigorous derivation, but rather we'll just state some basic facts about trigonometry and see how we can use them in dealing with vectors and other important quantities in physics when we encounter them. And the basic object that we'll be dealing with in the study of trigonometry is the right angle triangle. And the right angle triangle, as the name suggests, is a triangle which is made of three sides, where two of the sides, known as the legs, make a 90-degree angle with one another. And the third side, known as the hypotenuse, let me write the name here, is essentially the diagonal side that joins the two. And generally, we label the sides, instead of calling this the hypotenuse, we label the sides as A, B, and C. And there is a fundamental theorem of geometry that you might have learned if you took geometry, which relates the three sides. And this is known as the Pythagorean Theorem, after Pythagoras. And this theorem here states something very important about the three sides. It essentially states that the length squared of the hypotenuse is equal to the sum of the squares of the other two sides. Or alternatively, by taking the square root of both sides, we can say that the length C of the hypotenuse is equal to the square root of the sum of the squares of the two other sides. And this is an important theorem because essentially it tells us that if we know two sides, we automatically know the third. In this case, if we know A and B, we can calculate what C is. But more than that, this tells us that if we know any two sides, we know the third side, because we can solve the first equation here for any of the three. For instance, if I rewrite it here as A squared plus B squared is equal to C squared, and I want to solve this for A in terms of B or C, all I have to do is subtract B squared from both sides, and that will give me that A squared is equal to the difference of the two squares. And then, just like before, I will take the square root to get A equal to C squared minus B squared. And as I said, this is a fundamental theorem of geometry, and it's going to be important for us when we study vectors. But even more importantly, this tells us something important about the length of C. It tells us that the length of C is definitely not A plus B. In fact, as we will see later, the length of C is actually always less than the length of A and B. And you can sort of understand that if you were to walk along A and then along B, you'll get from your initial point here to your final point here, going along those two lengths. But you can do the same thing by walking directly from this point all the way up to this point. And in a sense, you can think of the hypotenuse in that way as a shortcut in getting from your initial point here, the left bottom corner, to the top bottom corner here. It's a concept that we will explore more later on. So let's do an example with this right away and see how this is done. And instead of doing the typical example that is done in every class, the so-called 3, 4, 5 example where you plug in integer numbers and you get an integer number, those are known as Pythagorean triplets. I want to do an example with actual numbers with decimals, because it will also prepare us when we calculate components and magnitudes of vectors, which in physics generally always come in decimal form. So the statement here says that a right angle triangle has two legs of length 345 meters and 5.07 meters, respectively. We can call these two A and B. It doesn't really matter which one we call A and which one we call B. So let's call this one here A, and this one here B, and we want to calculate the length of the hypotenuse. And in order to calculate the length of the hypotenuse, all we have to do here is use our Pythagorean theorem, square the two sides, take the square root, and then round it. And if we do that, we're going to get 3.45 meters, quantity squared, plus 5.07 meters, quantity squared, all square rooted. And I'll let you verify this. The answer will be rounded to 2 decimal places, 6.13 meters. So you can see right away that 6.13 meters is clearly less than the sum of 3.45 meters plus 5.07 meters, which in fact is 8.52 meters. So this is just to verify the statement I just made about the lengths. Now let's do another example. And what I suggest here is to stop the video and try to do it yourself first, and then restart the video and look at the solution. In this case, we have another triangle, but we're given the hypotenuse of the right angle triangle, which is 7.39 meters. And the vertical side, let's call it B, is 4.44 meters. And we want to find A. And again, we have the expression that A is equal to C squared minus B squared square rooted. Once again, we plug in the numbers. 7.39 meters squared minus 4.44 meters squared. And once again, verify it yourself. If you plug in the numbers here to 2 decimal places, you get 5.191 meters. And you can also verify, since you now know C, A, and B, that C is less than A plus B. And the last thing I want to say here about this is that even though you might have not taken trigonometry before, and you might have not seen the Pythagorean theorem, so you might have not seen, let me write it here once again, C equals A squared plus B squared. I claim that if you've taken algebra, you've already seen this. You've already seen this in algebra, and it was disguised in the form of something known as the distance formula. In algebra, when you plot a straight line in the xy plane, you have a straight line that runs somewhere here on the xy plane, and then you select 2 points, and you're asked to find the distance between these 2 points. And the way you do that is that you obtain the coordinates. Let's call this x1, y1 coordinates, which correspond to the coordinates here. And the coordinates here will be x2, y2 coordinate. And in order to obtain the distance of the blue line that runs between these 2 points, what you do is you calculate this distance here, and you calculate this distance here. And the distance, the horizontal distance between the 2 points is nothing but x2 minus x1, which is often labeled as delta x. And the vertical distance, likewise, is y2 minus y1, which is generally called delta y. And this distance here, d, is given by the square root of delta x squared plus delta y squared. Now, if you compare these two equations, you notice that they're essentially the same thing. We're essentially using the same formula. The distance, which is a length, is given by the square root of the sum of 2 squares. And the 2 squares here represent the horizontal distance and the vertical distance, which are analogous to the horizontal and vertical side of a right angle triangle. And really what we're doing here in algebra is that we're using the Pythagorean theorem, we're calling it something else, and we're relabeling the variables to be something else. But it is essentially the Pythagorean theorem. So even if you've never taken trigonometry, you're already familiar with this. In the next few videos, we're going to see how we can apply the Pythagorean theorem to the calculation of components and magnitudes and angles of a vector.